Hello. This presentation will be about some of the architectural views behind the Building Data Products, Data and Analytics Engineering for Non-Programmers books. This will be part of a series of presentation, going in a little bit deeper than what was covered in the book, a lot more pictures and discussion around some of the key architectural concepts geared towards getting an understanding of the overall architecture. In the first place we're going to start here is talking about the business problems and opportunities around that we're trying to solve for. So my name is Brian McMillan. I'm the author of Building Data Products, Introduction to Data and Analytics Engineering for Non-Programmers. Professionally, I've been an enterprise architect for about 15 years and focused on data and business intelligence architecture. So the first place we're going to start talking about what are the problems we're trying to solve for. So we've got a lot of we have a lot of problems that we could pick from. It's a target-rich environment to make a difference when we're delivering these data products. And the first place to start is let's talk about some of our own problems as developers. So the biggest problem we have is that our project's canceled. Now, why is our project canceled? It's canceled because the system grows less relevant, and we don't deliver on time. Those are the two big causes for why a project would be canceled. So this diagram here is a theory of constraints diagram looking at what you do with this diagram is you list out the undesirable effects, and then you start to do the cause and effect chaining, and then eventually you get down to something that is, at least at this point, the root causes that you can identify. So let's talk about why a system would grow less relevant. Well, a system would grow less relevant because we delay making changes and the needs of the business change and we don't understand the business value. Those are three good reasons why the system would grow less relevant. Okay, well, why do we delay making changes? The cost of making changes is high. There are many defects. So those are two good reasons. So it goes to say that if we can reduce the number of defects, and if we can make the cost of making changes lower, then we could make more changes. And if we could make more changes, the system would be more relevant. Likewise, if we don't understand the business value, then the system could grow less relevant. And if we don't understand the business value, then we end up developing many low business value features. And if we develop many low value business features, and maybe we have high staff turnover rates, we don't deliver on time. And then again, if we don't deliver on time, project's canceled. So these are a couple of good, this idea of taking this, it's called a current reality tree, and building it from the undesirable effects is a really good tool to help you identify what the root causes are. So what the root causes from a developer standpoint, what we're going to work on is we're going to work on making it easier to make changes. We're going to work on identifying and eliminating the defects that pop up. We're going to pay attention to the business side of things, like, what are the actual needs of the business? What brings the value to the business? And then we'll put some things in place to make the undesirable effect less likely to occur. So the next thing we want to do is we want to look at this business. We need to burrow down on what actually do we mean when we say business value. So business value is about solving real problems for the business. Preferably these would be problems that your customer is having if you're developing something for your customer. And here I don't mean our internal customer who we're developing some kind of data product for, but I mean our external customer that the company is delivering value to. So we can take the same thing. We can sit down, we can do the same strategy. We can list out a whole bunch of undesirable business effects. Like we have, things that may be a little bit more complicated to understand. We have insufficient protective capacity to buffer demand. We may need to talk with somebody to figure out what this means, to clearly understand a little bit better about what this means. Because as an IT person, these aren't words that I'm familiar with, just like the business isn't familiar with the words we frequently use. But some of these are pretty straightforward. We're unable to deliver on time. Our customers pay us late. The quantity sold fluctuates unpredictably, and our prices fluctuate unpredictably. These are all valid business questions, and these are the things that we should be solving for when we're trying to figure out what it is we should be working on. And some of the things you can do with this current reality tree is you can add some other things here, which is useful from a data perspective, like, we need to look at planned deliverables and what's our sales price. These are business concepts that we need to pay attention to, that we're trying to solve for. So let's burrow down a little bit more into whether or not we're really helping the situation. So we're going to focus on, we didn't understand the business needs or the business values. Well, why is that? So let's read this from the bottom up. So we've gone through this process with people. We have figured out what the root causes are. Now you can read it top down like we've been doing, or you can read it from the bottom up, which we did a little bit ago. So if we don't really know what's important and what's not, and we're drowning in information, then we don't know how to analyze the information to facilitate necessary changes. So that may feel like something that you've experienced before. We're drowning in information, whether it's us from our IT systems, or whether it's the customer who just has so much information they don't know what to do with it. So why is that? So we're drowning in information. Well, two reasons that we might be drowning in information are we seek to gather all the information we can, and that more information is generated over time. So this, we seek to gather all the information we can, is a common problem we have. This is the I want to know everything about everything problem, or solution, supposedly. So let's start with the business problems. Say we don't understand our sales pipeline and our sales are fluctuating. That's a legitimate business to solve for. We want to expose where and when that's happening. So we take the sales problem and we combine it with some of the problems we have. Like, we don't know what's important and what's not. And we instinctively believe that more information will help us. And we don't fully understand the cause and effect around that sales process because it's a complex system. So therefore, we're going to seek to gather all the information we can. And if more information is generated over time, then we drown in information. And if we're drowning in information and we don't know what's important or what's not, because the system's complex, then we don't know how to analyze the information to facilitate necessary changes. And therefore, we don't understand what the business needs and what the value we're bringing is. And if we don't do that, then, of course, we're going to do things, we're going to build systems that are not going to deliver the value we need, and those things are going to get canceled over time. So that's a set of tools you can use to analyze the problem, and provides a little perspective on the problem that's worked on inside the book. So another thing is thinking about, are we working the right way or not? So typical development process. I've got an idea, I develop my solution, I release it, and then I find out it's not useful. So I go do something else. I take another idea, I develop it, I release it, and it seems to be developing value, but over time, the value isn't providing, we're not getting the value we need. So that's a problem as well. So, the standard approach is let's be agile. So we're going to cut things into smaller bucket. We're going to develop smaller solutions rather than bigger solutions and just iterate over them. So we're going to get an idea, we're going to develop it, we're going to release it. And we iterate over that, and then we get user, but it doesn't really, we don't think it's really delivering enough value. So we continue to add on layers of development. We get user feedback, and what do they tell us? This isn't what I need. So that isn't a whole lot better than where we started. So what we'll do is we'll go find someone to help us out, someone who understands the problem. When we call these, sometimes we call them product owners. Sometimes we call them hippos. Hippo stands for highest paid person's opinion. So we're going to get that highest paid person's opinion, and we're going to bring them into the process sooner, and we're going to get their feedback, and we're going to do some development, and they're going to let us know that what we've done works. And we'll do a couple of iterations. We'll get then we deploy it to the people who are actually using it, trying to get value, and they say, well, it's not useful. Again, what value is the person who we worked with, our product owner, providing us if we didn't get, when it came time to get actual use by the real users in the field, they don't think it's valuable. So what we really need is we need a better product owner. So we'll go get a better product owner. So we'll take our idea, we'll develop it. Our product owner will provide some of that initial feedback and testing. We'll do a little bit more development. Maybe we'll introduce the concept of doing some testing. So we check to see as we develop new features, well, this feature is definitely improvement over what we had before. We'll do, commonly, the easiest way to refer to this is like A/B testing. We have feature A versus feature B, and we do some testing. And this can be very sophisticated. But the main point here is we need to evaluate if the changes we're making are actually increasing the level of value that we're delivering. And eventually we want to get to a point where it's good enough. It's sufficient to do the job and bring the value. And the question is, how do you know what to test against? And that's a big question, and there are lots of answers to that. And you have to figure that out. But it is something to pay attention to. It's not just enough. It may not be enough to do just a simple, is this feature better than this feature? You really need to think about testing. So what we want to do is we want to move forward and improve this process. And the first place to start is with understanding the product life cycle. So I'm just going to do a quick little overview here. Product life cycle can be thought of in a couple of different ways. When it starts out, we're in exploration. And in exploration, we don't really know what's going to stick. We try a bunch of things, and we try to find something that's going to work, that we can expand upon. And this is the expand phase, where we start to grow our user base, grow the amount of value we're delivering. Over time, it's going to be good enough. And we have a stable system where we can just start to extract the value from that system. And then at some point, all systems are going to have to be wound down. And we're going to have to figure out how to unwind the system, start reducing the value that it's delivering by pulling pieces and parts out. And maybe hopefully they get replaced by something that's going to deliver even more value, built upon the learning that we had from the original system. So let's take another look at this. So we get an idea, we validate it, we prototype it, we're in exploration, we do some user testing, we refine it. testing gets a little bit more sophisticated. We refine it, we test that, gets a little bit more sophisticated. We get to this good enough point, but even that isn't good enough. Over time, this system is going to become less and less useful. And that's our key to knowing when we should start winding things down and exiting. So what do we do now? We get a new idea. Well, we need to do some validation, and sometimes it doesn't work out. So we get another idea, and we validate it. Maybe the validation passes, and we do a little prototype. We do a little bit of user test, and we find out, nope, that's not the right problem we should be working on. So we get another idea based on that feedback, and we validate it, we refine it a little bit more, and we get to a solution that's not just good enough, but it's a great solution. And the key here is in this early step here, this validate, prototype, refinement. What we end up doing is we end up testing a whole bunch of things until we find the one that's worth doing, that's delivering the value, that's taking off. And a lot of this boils down to testing your assumptions and trying to get through this explore phase as quickly as possible. So one of the ways we can take that, we can think about what it is we're going to build, what it is we're going to validate, is to think about them as bets. We're going to make a bet that the sales manager needs a data discovery platform. And this is what we're building in the book. So what are the top selling products? So we talk with the sales manager, and we determine from her that these are the top, that I don't really have a good idea of what the top selling products are. And I definitely don't have a good idea of what products need my attention from day to day. So where we're going to start is we're going to build a data discovery. We're going to give them a product that will let them get some insights out of the data, and will let them discover what's really inside their data. So from a developer standpoint, what we want fast feedback as to whether the software developing is actually useful. And in the traditional software development, like the app on your phone, one of the techniques that is being used is this idea of DevOps, development and operations working simultaneously side by side. And that has some features that are they're really foreign in the data and analytics space for the most part. So what would it look like if we applied DevOps style development to the data and analytics space so that we could get fast feedback on whether or not the software we're developing is valuable? So we're going to, as part of delivering that, we're going to deliver a couple of things. We're going to make a bet that one of the keys for data work is having a good, effective orchestration pipeline that we can build. That orchestration pipeline is going to is necessary to provide the data to that data discovery platform. And in that data discovery platform, we want to focus on providing ad hoc visualization and data access. Now, one of the other things we want to explore is about how we deploy the data. Traditionally we deploy data products. We think of them like we have our database, our data warehouse, and we have our data sources. Our data sources go through some kind of pipeline, ETL process, whatever. They are loaded into the data warehouse, and then there's some kind of visualization tool on top of that. And those are big monolithic applications. But what we want to take a look, we have an opportunity here to do something a little bit different. And because if it is true that our desire to collect all the data we possibly can collect is a problem because it's overwhelming us, And if we can work with our customer to get an understanding of what they need and what's really bringing the value, and we can focus on the value, we would need less data. What would the deployment look like rather than having the BI infrastructure, the ETL infrastructure, the data warehouse infrastructure all separate? What if we bundled all those things together and we deployed them we deployed those things all together? And we in effect, the architectural pattern here is, for lack of a better term, is called the bake data architectural pattern, where we're baking the data into our application. And if we can bake the data into our application, then we can make use of serverless hosting platforms, which allow us to scale it up and, more importantly, scale it down when it's not being used. Scale it down to nothing. Basically turn the system off when it's not being used. Why should you pay for a data warehouse platform in the middle of the night when no one is using it? You shouldn't. So by adopting a serverless deployment pattern, we're making a bet here that we can deploy a data warehouse that will scale up when we need it and scale back down to nothing when we need it, so that the charges, we have clear visibility to the charges and the utilization of our system. Which again, if we know whether the system's being utilized or not, we can then make good business decisions about where we should invest more development effort. So at the end of the day, we want this data discovery platform that provides a good, clean, ad hoc environment. And, it doesn't need to be very fancy and pretty, but it does need to do some things. We need to be able to see the data that we have. We need to be able to build, interactively build our arts and charts to analyze the data and get some idea about what the data looks like, because that's helpful to us rather than looking at a big table of data. We need to be able to provide some more programmatic interfaces to this data, whether it's a JSON data set that can be consumed by some other application, or a CSV file that we can pull into Excel, or a file that we can manually edit. We also need to be able to provide canned reports so that, when we discover a view of the data that makes sense, make it very easy to get the information in front of the people who need to make the decisions. And then finally, like I referred to before, we need to get visibility to how the system is being used and how we're being charged for the system. The key here is, one of the keys, again, we talked about the orchestration platform that we want. The orchestration piece should be easy to think about and develop and manage for people who are non-programmers. So this little thing that just popped up here is the orchestration task to build this static report GUI. We've got a title, we've got a template to use, we've got the URL, the data that will consume the data coming from, in this case, it's this JSON data set. And then we want to know, what we're going to publish this in our system. So that's pretty straightforward. It is all code. It doesn't require you to use it to build a GUI application. It doesn't require, there's no GUI application to build the pipeline. There's no GUI application to build the interface. But it's just configuration. So it is a step above, it's much more complex, but frankly, not that difficult for someone to get a grip on doing the development. Basically, it's just configuring things and knowing this needs to happen before that. So that's basically an overview of the problem space that we're addressing. Some of the problems about the ways we typically work, and some of the bets we want to make that we're making and investigating in the book, Introduction to Data and Analytics Engineering for Non-Programmers. If you have any questions, feel free to contact me. I'm active on Twitter. You can send me an email to the email there. The book is available on Amazon, Apple iBooks, Gumroad. If you have any questions, please feel free to reach out. I'd love to talk to you about some of the problems that you're facing and some of the ways that you might be able to go about addressing some of those problems. Thank you very much.